In space, not everything is visible. Some missions are announced with cameras and press conferences. Others launch quietly, disappear into orbit, and return months later without explanation. One of the most mysterious objects in Earth's orbit today is the X-37B. Officially known as the Boeing X-37B Orbital Test Vehicle, this small, robotic spaceplane is operated by the United States Space Force. The Pentagon describes it as a reusable platform designed to test new space technologies. But its secrecy, long missions, and advanced maneuvering abilities have made it one of the most closely watched military space assets in the world. Unlike traditional satellites, the X-37B doesn't just stay in one orbit. It can move, it can change altitude, and most importantly, it can return to Earth. The vehicle looks like a miniature space shuttle. It launches vertically on top of a rocket, enters orbit, and operates autonomously for months, sometimes even years. When its mission is complete, it re-enters the atmosphere and lands on a runway like an aircraft. No astronauts, no public mission briefings, very few details. And that mystery is exactly what makes it powerful. The X-37B operates under what many analysts call strategic ambiguity. Because the United States releases very little information about its missions, rival nations like China and Russia are left guessing. Is it testing new surveillance technology? Is it experimenting with anti-satellite capabilities? Could it be carrying systems designed for electronic warfare in space? No one outside a small group of officials truly knows. And when your rivals don't know what you're capable of, they have to assume the worst. That forces them to invest more money, more time, and more resources preparing for multiple possible threats. In strategy, uncertainty can be as powerful as weapons themselves. Another major advantage of the X-37B is reusability. Most satellites are launched once and stay in orbit until they fail or run out of fuel. If a new mission is needed, an entirely new satellite must be built and launched. That takes years. The X-37B changes that model completely. Because it can return to Earth, engineers can inspect it, upgrade it, install new payloads, and relaunch it relatively quickly. That flexibility allows the United States to adapt its missions in ways traditional space systems cannot. One launch might focus on testing new sensors. Another might carry small experimental satellites. A future mission could test new materials or communication systems in the harsh conditions of space. Each time it launches, its purpose can change. That makes it unpredictable. Its payload bay, roughly the size of a pickup truck bed, may not seem large compared to massive satellites, but in modern space technology, small does not mean weak. Compact satellites, jamming systems, or experimental devices can all fit within that space. Some foreign analysts have even speculated about the potential for orbital weapons. While there is no public evidence that the X-37B carries weapons, its maneuverability and proximity capabilities raise concerns. Unlike traditional satellites that stay in fixed orbits, the X-37B can adjust its orbit. That means it could theoretically move closer to another satellite for inspection or surveillance. In the wrong scenario, that kind of capability could also be used for interference or sabotage. This ability signals a broader shift in space doctrine. For decades, space was treated as a passive environment. Satellites were launched, placed into orbit, and left there. But modern military thinking sees space as a contested domain. Satellites are vulnerable. They can be jammed, they can be tracked, they can even be destroyed. The X-37B represents a move toward resilience and maneuverability. Instead of relying only on static satellites, the United States now has a reusable, mobile platform that can adapt and respond. That flexibility makes it harder to target and harder to predict. And this program is no longer experimental. The X-37B has completed 7 successful missions. Each mission has lasted longer than the one before. Some have remained in orbit for hundreds of days. The most recent mission launched in December 2023, demonstrating that the program is active, funded, and continuing to evolve. Longer missions suggest growing confidence.
They also suggest that whatever technologies are being tested are functioning reliably. For rival nations, that sends a clear message. The United States is not just experimenting in space, it is developing operational capabilities. Some analysts even suggest that in the future, multiple X-37B-like vehicles could operate together, creating coordinated systems in orbit. While that remains speculative, the possibility alone forces competitors to prepare for a new kind of space competition. In the end, the true power of the X-37B may not lie in any single piece of hardware. It lies in uncertainty, it lies in flexibility, and it lies in the message it sends that space is no longer just a place for observation. It is a domain of maneuver, strategy, and influence. As technology advances and geopolitical tensions grow, platforms like the X-37B could shape the future of orbital operations. And the world is watching.